Hello and welcome to 9.4, multiply square roots. We look at two objectives here, to multiply square roots and to use polynomial multiplication to multiply square roots. This is an extension of the previous section, add and subtract. And so the next operation is to multiply. And so we're looking at the properties to help us do that. We will not be looking at division of square roots. And so we kind of stick to this. Now, previously we saw that if you had a number, we could split it up. Like, for example, let's say square root of 20. I think that was the example we saw, where we looked at 20 as two factors, one of them being the highest square root. So we wrote or rewrote the 20 as 4 times 5, and then we split it up into two separate radicals, right? That's what this property is kind of teaching us, okay? This property says, well, if you have 4 times 5 within the radical, you can split them separately. Again, remember, this is true only for multiplication. You see that multiplication symbol there, then you can do this. If there is a plus or a minus, as we've seen in 9.1 examples, you just cannot do that. You cannot split it like that, okay? So this is a product property. And the reverse is also true. When we say it's a property, the reverse is true. If I have them as two separate radicals, I can combine them under the same radical. So let me give you another example. So if I had, let's say 6m, okay, square root of 6m, I can split, because there are two factors here, I can split it up as 6 square root of 6 times square root of m, okay? And what it says is, if I had it instead as, two of them, if I had it as 17, square root of 17, and square root of y, right, that are being multiplied, I can shove them together under a single radical as 17y, square root of 17y. That's what this property says. This is all true only with multiplication. Just bear that in mind. Let's look at the first problem. Square root, or we have two parts, so let's look at part A. Square root of 2 times square root of 6. As per the property, you're looking for the multiplication symbol, right? That's there. And these two are separate radicals. And the radical, the product property allows you to multiply these two under the same radical, right? Which is 2 times 6, 12. Box it. Okay. Let's look at B. It looks slightly more complex than the other one. Not too bad, we can handle it. Okay. Again, remember to look for the multiplication symbol. Yes, there is multiplication. It's not explicitly a dot, but it's a parentheses, so you know that's going to work. Now, I'd like you to focus on the 4 and the 2. These two numbers do not have the radical, right? They're just plain numbers that are being multiplied to the radical. So you could multiply these two non-radical numbers because of the multiplication happening. So 4 times 2 is 8. Then let's focus on the radicals. Okay. They are not identical, but remember, identical radicals only work for addition and subtraction. Here, this is multiplication. Rules are pretty relaxed. All they're saying is if you have multiplication going on between them, you can simply get this 3 from here and get that 12 from there and multiply them together under the same radical. Okay. So I'm going to switch back to black. This was just for color coding. So you have 8 square root of 3 times 12 is 36. Yeah. 3 times 12 is 36. What's really nice is now you look at this radical as radical of 36, root 36, which is a perfect root. So that simply becomes 8 times, there is a times there, right, when they're shoved together. 8 times 6, which is 48. And just like that, that huge expression simplified into a nice simple number as 48. So we need to bear in mind that radicals, if they're being multiplied, and they're separate and they're being multiplied, they can be shoved together under the single radical. And if you have non-radical numbers that are being multiplied, you will multiply them as regular numbers because they are regular numbers. Okay, let's take a look at this problem. Here we have A, square root of 8x cubed, and square root of 3x. Okay. Again, you see the parentheses there, you know, that's multiplication going on, which means that you could use the product property to bring them all under the same radical. So 8x cubed from here and 3x from there are being multiplied together under the radical. So that means all this has to be simplified in here. So 8 times 3, 24. X cubed times x. Remember again, product rule, power rule, all these rules come from exponents, right? So when I have two bases that have identical base with powers that are being, with different powers that are being multiplied, we add the powers. So I'm going to show the adding of powers explicitly here. 3 plus 1. Where did the 1 come from? The 1 is the power sitting above this x. All right, so that is square root of 24x power 4. Okay. And now we need to pay attention to see if this can be simplified as we saw in the previous section. So to simplify this, you want to split this up. See if it is possible to split this up as a perfect root and another factor. So scanning through all the possibilities, I get 4 and 6. And x power 4, again, if you had a power 2, that's perfect. Now we don't have a power 2, so you're looking at x power 4. The power is even. You have to go back to that lesson. Okay, go back to that video if you've forgotten already. If it's even power, you're going to write that as x power something the whole squared. Right? In this case, it will be x squared the whole squared because 2 times 2 is 4. If it is an odd power, you split it as 1 and the highest even power, and then split that even power. So the 2 steps involved if it is odd. So here we're doing good, and we will now have 4 times 6 times x squared the whole squared, all happening under the radical. One more shot at splitting them up. And finally simplifying it. So you have 2 from here. Square root of 4 is 2. Square root of 6 is not a perfect root, so leave it like that because it's already in the simplified form. And square root of, I'm sorry, no square root. What I was trying to do was show you the cancellation. And then that is x squared. As always, bring all your numbers and letters together and leave the square root right at the end. And that is the answer for this problem. Okay. Let's try this for part B. Or you could put the dot, or you could just keep the parentheses as you see. The y cube, let's remember to copy the question correctly. Most often that's a challenge too. Okay, so you have 20y squared from the first radical times 5y cubed from the second radical. 20 times 5, 100. Y squared times y cubed is y power 2 plus 3. So let me write that one more step, 100y power 5. Okay? So let's do the split. Now what about 100? 100 is wonderful because that is already a perfect root. I'll just say perfect root. Okay. What about y power 5? Now this is odd power. So we have some extra steps, so I'm going to write it out here. If it's even power we were able to handle that in part A. But y power 5 means it's y power 4 times y power 1. Then you will work out the y power 4 as y squared the whole square times y power 1. And that's what I'm going to bring here when I split them up. Okay. So I'll keep the 100 here because we know that's a perfect root. And that's going to be y squared the whole square times y power 1, all under the radical. One more step of splitting them up individually. Times y. I'm not going to put the power 1 because it's redundant. Okay, square root of 100 is a perfect 10 times, remember again, the root and the power will undo each other. That gives us y squared. This one cannot be simplified, so square root of y. Shove them all together, 10y squared, square root of y becomes your answer. All right. Okay, how do you handle this one? It says square root of 2 the whole squared, square root of negative 11 the whole squared, because the whole thing gets squared. Again, not a problem, because we know what the square means. Square means that number is multiplied twice, right? So I will simply write it as square root of 2 times square root of 2. Right? The power tells me how many times to multiply it, multiply the base. But now we need we can use the the product property, which allows us to multiply them together under the single radical. So 2 times 2, square root of 4. That's wonderful because square root of 4 is nothing but a 2. And that right there is your answer. Okay. So it's not really as bad as we thought. Okay. So here also the square root and the square did undo each other, but we could see that through product property. Negative square root of 11 the whole squared. Now remember, the base is with the negative. The whole thing is being squared, right? That's your base. Again, you have to go back, way back to when we learned about the flag and the flagpole, right? The flagpole is your base, the flag is your power. So what is the flag attached to? The flag is attached to this base, which is negative square root of 11. It's very important to identify this so that you know that you have to multiply negative square root of 11 twice. Okay, negative times negative is positive. So that simply becomes, it's positive. I'll just put, again, you shouldn't be doing the plus explicitly like that, but I want to show you that I handled the minus because they both happened outside the radical. So you can easily combine them. So minus and the minus is a plus. And then I brought the radicands, right? The radicands were just the 11. They came together. So that's going to be square root of 121. Again, if you look at the table, if you use your calculator, you know that 121 is a perfect root. So your answer is 11 there for part 2, part B. How do we use polynomial multiplication to multiply them? So let's take part A. Again, this is very, very intuitive. What do you think will work here? Yes, quite obviously the distributive property. So just for clarity, the first step, I'm going to write it very explicitly. 3 times 5 is 15 minus 3 root 2, because the root 2 is in its simplified form. Nothing can be done further to it. That's your answer there, right? As I promised, it's very intuitive. The second one is slightly complex, so let's see. Same idea. It's complex because you just have extra stuff to do and you're multiplying a square root instead of a regular number. Distribution always works. Don't skip steps. Let's do them as we see them. Minus square root of 2 times square root of 10, right? Now this is square root of 2 times the 4. So we just bring the 4 in front and then put the square root of 2, because really there's no compatibility, right, to multiply them. We just put them right next to each other. As always, the square root comes at the end. That's why I throw in the 4 in the front. And here you have two radicals, separate radicals. So product property allows us to bring them together. 2 times 10, square root of 20. Again, we've done this 20 thing several times. So the 20 splits up as 4 and 5, right? Minus square root of 4 times 5. Split that up. Okay, so 4 root 2, you can see that the 4 root 2 is just tagging along. There is no work there. All action is on the second term. And square root of 4 is 2, root 5. Now look at these two. They are not identical, right? So I will say unlike square roots. So you really cannot simplify these two. So you just have to write it out as you see it, as 4 root 2 minus 2 root 5. And this will be your final answer here. It is the simplified version. And we couldn't just go further because of unlike square roots. All right, let's look at the last problem. Square root of 5, 7 plus 2 square root of 5. Okay. Again, same properties, distribution and all that. It's just that it looks different, may look a little more complex than the previous one, just because of the extra square roots you see. Let me write that properly. Okay. So that is square root of 5 being multiplied to the 7 and square root of 5 being multiplied to the 2 root 5. Okay, as always, you look for a compatibility here. Now this is a plain number, this is a square root. You cannot multiply them. So shove them together with a number in the front. Plus, you have again this 2 that is not inside the radical. So bring the 2 out here and multiply. You have square root of 5 and square root of 5, two separate radicals. Bring them both under the same radical. 7 root 5 plus 2 times square root of 25. 5 times 5. That's really nice because 25 is a perfect root. So 2 times 5. So 7 root 5 plus 5 times 2 is 2 times 5 is 10. And there's really no radical here. They are not like terms. And so we just box this as the final answer. Again, this is a good time for you to pause and try part B. Let's distribute. Square root of 6 times square root of 2 plus square root of 6 times square root of 18. This problem, all of them are radicands, right? You don't have any numbers in front of the radical sign. So it's kind of, in a way, easier because you're just focusing on the radicals. Again, two separate radicals being multiplied, bring them all together. Okay. This is kind of easy because 6 times 2 is 12. Now multiply these two. That gives you 108. Okay. Now square root of 12 and square root of 108, they are not identical, so you cannot combine them. But you certainly have to see if they can be split further. Again, looking at all the options, 12 will be 4 and 3 highest perfect roots you can find. Okay. What about 108? 108 and 9 will work. Let me just put it out here. Okay. I mean, 9 will work for 108, so 9 and 12. Okay. But again, 9 is not maybe not the highest you can find, right? So divide by 14. I'm sorry, not 14, 16. And that gives you, let me show it here, 16 and 6.75. That didn't work. So let me just write it out here. 1, 4. These are the perfect roots, right? 9, 16, 25, 36, and so on, right? I'm just basically hunting for the highest power. So I know 25 won't work because it's 108, right? I tried 16, 16 didn't work. But I tried 36, and 36 works like a charm because even though you have 9 and 12, 36 is the highest perfect root you can find. So that's 36 and 3. 4 times 3 plus square root of 36 times 3. Right, let's split it up. Times 4 times 3. All right, square root of 4 is 2 root 3. 36 is 6 root 3. And we stop at this point and see if these are identical. Yes, they are like square roots. So we're good to go further and do 2 plus 6 to the square root of 3, which is nothing but 8 square root of 3. And that is our final simplified answer. Okay. So I hope that helps with this section and in fact this chapter. I will see you in chapter 10 in the next video.